Hello, everyone. My name is Molly Halsey, and I'm the event specialist here at Enterprise DB. I will be your host today for our webinar, Logical Replication and PostgreSQL. In PostgreSQL. I'm joined by I'm joined by Sorry, we have a little feedback going on.
Sorry about this, folks. This happens once in a while. If we had somebody who could do like a song and dance to entertain everyone, that would be cool. But unfortunately, you just have to stare at us until we get it working.
Hello?
Okay, Bruce, are we audible now?
Yes.
You can hear us?
Yes.
Yep.
All right. I'm joined by Bruce Momgen, co-founder of PostgreSQL Global Development Group and database architect, Mark Linster, Senior Vice President of Product Development and Support, and Kuntal Ghosh, a software engineer here at Enterprise DB. Before we get started, I just want to go through a few housekeeping items. This presentation is being recorded. We will be sharing the recording along with the slides after the broadcast. The lines are currently muted. If you have a question, please feel free to submit it in the question panel. Today's session is scheduled for 1 hour. We expect the presentation to last most of our time today, and we will allot any extra time for Q&A. If we do not have time to address all questions, we will follow up afterwards with any attendee whose question was not answered in our follow-up email. And now, without further ado, here are Mark, Bruce, and Kuntal.
All right. Thank you very much, Molly. Okay, sorry about the little technical glitch there, but you know, that always can happen if you do something live. So this is for this year, the last one in the series of Pulse of Postgres, which we started with, installing in containers, Windows, Linux, etc. All these recordings are available. So today we're going to end, as Molly said, with logical replication in PostgreSQL. We will pick up again on January 22nd of next year with a webinar on how to use open source software to monitor Postgres in production. That's going to be on January 22nd. Okay. So today, as Molly said, we're going to talk about logical replication in Postgres, and Kuntal is going to give us a step-by-step approach of how to do it. So let me just get into this. First, I'll talk very briefly about who is EDB. Promise won't take more than a few minutes, and then we'll start diving into logical replication in Postgres. Really important is, if you ask us a question and you give us, a shipping address, a business address that we can ship to, we'll ship you a pair of nice EDB socks, which, especially for us now in Boston, are starting to come in really handy. Kuntal can probably not really relate to why one would want warm socks, but at least up here, they're handy, and even if you don't want to wear them, they're sort of nice looking. Okay, so give us a question, give us a shipping address, and we'll get you a pair of socks. So now, without further ado, let me go into who is EDB. EDB has been around since 2004. That's when we were founded, and we've been contributing to Postgres since 2006. And we proudly call ourselves a global leader in the open source Postgres community. We've been providing software and services now for 13 years. Gartner and Forrester have recognized us as a leader in the relational database management space, and I'll talk about that a little bit more, but promise just a few minutes. We are active worldwide with over 300 employees with offices around the globe and a very large customer base. And as I said before, we are a major Postgres community contributor. So I mentioned Gartner before. Gartner has mentioned Postgres, Enterprise DB Postgres, for now 7 years in the Magic Quadrant. Since they restarted the Magic Quadrant activity in 2013, Postgres, Enterprise DB Postgres has consistently been in the Magic Quadrant. And if somebody wants access to that report from Gartner, just drop us a line in the questions, and Molly will send that report out to you afterwards. The reason why this is interesting and important in this context is we are not just a technology company. We're a company working with thousands of customers around the globe for very large implementations. And when we talk about technology, yes, we love the technology, but we really put the technology into the context of our business, of our customers' business. And that's also how Gartner sees it when they judge us in the ability to execute and the completeness of vision. That's really a recognition that Postgres is now at a position where enterprises can use it in earnest, or as we sometimes say, in anger, for real production applications, and be comfortable that it will perform just as well as many of the other commercial systems that they may have relied on for years. This has positioned us to work today with over 4,000 customers around the world. A significant part of our business is in North America, but a very, very large part of our business is in Asia Pacific and in Europe, where we work with lots of large brand names. Here are just a few that we are allowed to name. And Bruce and I work with many of these customers, and rest assured, they're not using Postgres for little departmental applications. They're using it for real, for mission-critical deployments. So, but we're not just active on the commercial side. We're very, very involved in the open source side. And Bruce, do you want to talk to this a little bit?
Sure. Enterprise DB was founded in 2004, really to provide at that point an alternative to Oracle. I joined in 2006, and since then, Enterprise DB has been focused on working with the community to help it grow, because a lot of the innovation that you have within your data center comes from open source. Open source does a very good job of innovating, Postgres being no exception there. So a lot of our innovation comes from Postgres. Obviously, we do a huge amount of deployments in Postgres. Oracle compatibility is still part of what we do, but of course, supporting open source Postgres is also a big part of what we do now. And this is just a list of some of the people that we have. Again, I've been here for 13 years. Dave, next to me, has also been 13 years. Robert, I think, is 9, maybe 10. So maybe 11, I'm not sure. Anyway, basically, we have a good stable of people who are working full-time in the community, and our teams working with other companies who also, we probably have dozens of companies who also have full-time staff working in the community, are able to produce a really excellent database every year with 175 new changes and features. And it's what has helped us grow. It's what has helped us innovate, and it's what's made Postgres so exciting for people who want to use basically a database, that's open source. We're kind of it for open source relational databases, and the relation's not going away. So we have decades to go, I think, sort of continuing to work within this environment, and it's a pleasure to do it. I travel about 90 days a year, and I get to talk to a lot of customers, a lot of conferences, and I just love it.
All right. Thank you, Bruce. Thank you. So today's focus is going to be on logical replication in PostgreSQL. Really fantastic capability that more and more people are starting to take advantage of, be it in the core replication in the Postgres server, be it through tools like BDR, or be it through tools like EDB replication server. Before we dive into this, we have a quick poll that Molly's going to run now, and the results of this poll will be shared with all the attendees afterwards. So please take a moment here to go through it, fill in the questions here. We're seeing the votes come in very, very rapidly. 30% of the audience have voted. Please, everybody else, express your opinions. It's very, very interesting here. Come on, we're at 60%. We still got, a couple of hundred people who have not voted. give us your opinions. So, okay, the poll is coming to stability here. We're going to give it another 5 seconds, and then we'll cut off the vote. So, 3, 2, 1, go. Okay, so this is what we're seeing now. So we're seeing 34% of the audience is using streaming replication today. Now, that's low, and I'll tell you why in a second. And they're using native Postgres logical replication, and then, yeah, some others are using PG Logical, Sloaney, or BDR. Sloaney is not really logical replication, but still want to make sure people do use replication. But bluntly speaking, the fact that 44% are not using replication, which basically means you don't have a standby, you don't really have high availability, that sort of worries me, because you're missing out on an opportunity to let Postgres be what Postgres can be. So now enough of my comments about this. Let me go back here, and we're going to make Kuntal the presenter. Okay, and he's going to take it forward from here. Okay, Kuntal, it's yours.
Okay. Thank you, Mark. So today I'm going to talk about logical replication. So it seems from the poll that a lot of people know PostgreSQL streaming master standby replication. So it has been part of PostgreSQL for years and is commonly used for high availability, as Mark rightly said, and it is also used for read scaling. So why add another replication mechanism? Well, the traditional replication is all about replicating the entire database or nothing. It's just copy of the master database. As long as, so for most of the customers, that is okay. So as long as you have a master and a secondary server, they are happy. But there are some specific use cases where logical replication will be really helpful. For example, what if we want to replicate part of the database? It can be a single table, multiple tables from a particular database, or some actions on a table. For example, insert, updates, all these kind of things. So logical replication enables us to do all this, actions to replicate all these things. And next, another major thing is online upgrade across major versions of PostgreSQL. So with logical replication, you can actually upgrade from 10 to 11. But if it does not have the backward compatibility feature, so you cannot replicate from 9.6 to 10. For that, you have to use PG Logical. But all the future versions of PostgreSQL 10, you can use logical replication. Then it also enables us to write in the standby server. So you can actually update the replicated data. It is also useful for auditing, so you can track all the events happening in your database through logical replication. It also enables us to give access to different set of users to different part of the replicated data. And it also has cross-platform replication. So for example, you can replicate from different operating systems. So how does it work? So in this case, it follows a publish and subscribe model. So you have a publisher instance and you have a subscriber instance. On the publisher instance, you can create publication which will publish multiple tables. And on the subscriber side, you have to create subscription that will connect to the publication. So you want to replicate those tables to the subscriber end. So once you create the subscription, a subscription slot will be created in the publisher instance, and a wall sender process and logical replication worker will be spawned. So wall sender process will take the wall, decode it, filter whatever is needed for whatever changes are needed for that table, and send those changes to the logical replication worker. That logical replication worker then applies those changes in the tables. So you get replication for those particular tables. Next is, what are the steps? What are the different phases that we follow in logical replication? Well, initially you have to create the publication and subscription. So when you do that, it will automatically create a replication slot on the publisher side. The next phase is table synchronization phase. In this phase, actually copy command does the work. So whatever existing data you have in the publisher table, it will get copied to the subscriber. And once that is done, all the real-time changes will be sent by the wall sender process. So it will decode the changes from the wall and send those changes to the subscriber. And logical replication worker will, in the subscriber, apply the changes in the subscribed tables. So what are the replication criteria? So the table, both the table must exist in the publisher and subscriber side. So till now, logical replication does not support DDL command. DDL commands will not be replicated using logical replication. So in that case, the table must exist. It also mapped by all the objects are mapped by name. So the table name should be same in both publisher and subscriber. The column name has to be same, but the column order doesn't matter. So the subscriber can have more number of columns, add columns, alter columns. So that still works, but the name has to be same. For the column type, it has to be same column type, or different types are allowed if that column can be converted implicitly. The type can be converted implicitly. For example, from int to float, that is also allowed. So I'm going to do a quick demo, but
Let me just ask one question here, Kuntal. The table has to be a logged table, right? If you flag the table as not a logged table, then it will not be subject to logical replication, correct?
Yes, it has to be log table. We need information. We actually extract information from the wall. So yeah, it has to be log table. So these are the steps we are going to follow for our demo. So we are going to create a replication user. Then we'll set the wall level to logical. So it will store some additional information in the wall to enable us to do the logical replication. Then in the publisher instance, we have to create the publication. Then we have to grant the select privilege on the published table so that the copy command works there in the table synchronization phase. Then we have to create the target table in subscriber, as I have already mentioned that DDL is not supported in logical replication. And finally, we have to create the subscription. Okay. So these are different monitoring things that I'll show in the demo. So PG stat replication, PG replication slots, PG stat subscription, and PG stat activity. Okay, so let's dive into the demo. So I have configured one publisher on my left side of the screen and one subscriber on the right side of the screen. So both the system is on my local instance. So I have used two different ports to run the servers. So I am using 54321 for the publisher and 54322 for the subscriber. So let's see the list of the databases. So we have a database called pub. So I want to logically replicate a table from the database pub to the subscriber. So let me first connect to the database. Yeah. So I want to logically replicate this table called T1. So this is the entry. So I have written the steps also here so that I don't have to switch to the presentation. So first thing we have to do this create replication user and configure to allow replication, we have to configure in the hba.conf file. So let's do that. First we create role. So it must have the replication attribute because it is a replication user. It has to have the replication attribute while creating the role. Okay, role is created. And I need to add the entry in the pg_hba.conf file. Okay, so I can just okay. So the next step is I have to set the wall level as logical in the publisher side. Okay. So the PG, for changing the PG HBA, I don't have to restart the server, but since I have modified the wall level, so I have to restart that server. Okay. Okay. So the next thing is we have to create the publication on the publisher instance. Okay, so let's do that. First, I need to connect to the publisher side. Okay. So I'm creating the publication for table T1. Here you can mention multiple tables, or you can create for all tables. For all the tables in a database, you can also mention this command. So I'll show that in the presentation, all the supported commands. Okay, so this is done. Now I have to grant the required privileges on the publish table to the replication user. Okay, so our publication side is configured. Now the next thing we have to do is in the subscriber, we have to create the target table. Now the easy way, the best way to create the target table is using pgdump schema only. So for that, we are going to use pgdump, then the table we are willing to replicate, then -s. This option is for schema only dump, then the table, then the port we are connecting to. Okay, so this is the pgdump script that we are going to run on the subscriber side to create the target table. Let's do that. Oh, and actually, I have created another database in the subscriber side. So I will replicate the table to the sub database in the subscriber side. So you can change the database as well. Let's do that. Well, it's done. We actually don't need the role replication user on the subscriber side. So that is not needed. Let's see. Okay. So the table is now replicated. Now the schema is, we have created the table in the subscriber side. So currently it does not have any content. So for that, we have to create the subscription.
Kuntal, do the indexes go across as well?
No, no, no. In this case, since I have taken the PG dump, so the index, we have also created the index on that, but that is not necessary. So the schema can be different.
So the indexes are really never replicated, and you can create your own indexes independently on the subscriber.
Yes, yes, that's true. So we are going to send all the logical changes, and in the subscriber side, if it has an index, then index entry will be created automatically. Otherwise, if you don't have any index, then it will not be there.
Yeah, and that's another nice advantage of, as you
Yeah.
said, you can write to the standby, and the ability to create custom indexes. Maybe you're doing data warehouse on the standby, and you want
Right.
indexes, and you don't want the overhead on the prime on the master. That's a nice feature.
Correct.
Or even
So
go to materialized views on the standby and do things like that, where you can have a standby that is a read optimized replica, not just a strict replica. That's, I think, it's a very, very nice concept.
Yeah,
Yep.
it really is. And I'm not sure how many people picked it up, but some people might have thought to get the schema over, we'd have to write to a file and then load the file on the subscriber. But he's basically in that PG dump line. He's from one machine. He's piped it to having PSQL connect to a different machine, and then he just pipes the PG dump script right into PSQL on the remote machine. So that's how we did it in one command instead of having to make a file and then go to the subscriber and load it manually.
Yeah, right.
So I always like the there's always a whole bunch of different options you can do.
Yeah. Right. So the next thing we have to, this is the last thing that we have to do, the create subscription. So let's do that, and we'll be done. You need to mention the connection string. In my case, it is localhost. Port is 54321. Then the database we are going to use pub. I think I covered. Yep, the user. I have to do it. Okay, the next thing we have to mention the publication that this subscriber will connect to. Here you can mention multiple publications. So one subscriber can be subscribed to multiple publication. So you can pull changes from multiple publications. Okay, so as you can see, there is a replication slot is created on the publisher side. I'll show you that, but let me just show you that everything got replicated.
So it created an initial snapshot of the table and made sure that all that data got applied.
Right. It used a copy command to take all the table from publisher and then applied those in the subscriber side. It didn't decode from the wall in this case. So after this, whatever changes I'm going to do, it is going to take the changes from wall and replicate it in the subscriber.
Okay.
So let's connect to that. Okay.
Spelling error there.
Okay, now let us insert a value here. And we can check that it also gets replicated. I can also perform update. And you can see that it's replicated. Same for the delete.
Oh.
Okay, and you can also execute truncate. That will also get replicated. Yep. So next, I'll show some monitoring monitoring useful monitoring metrics that will be helpful to see actually what is happening in this replication.
I actually wanted to ask a question. I'm wondering how many people really understand this is possible in Postgres. You know, I haven't seen this kind of demo in a couple of years, and there was a huge amount of complexity that went into making this happen. So I wasn't on the team that was really responsible for that, so I haven't been really focusing on it. But when you see it kind of set up this way and how cleanly it kind of works, it's really
Super
incredibly
easy.
creative.
Super. Yeah.
You know, we have binary replication, as everyone knows, which replicates everything, but the control that you get here, and I don't know if you're even going to go into the complexities of some of the stuff you can do. Like, you can have 10 machines all sending into one machine, right? So you can have one subscriber that has pulling data from 10 different publishers, or you can have one publisher that goes to 10 different subscribers, a broadcast, you know.
Right.
So you can both do the aggregation of multiple and a broadcast kind of capability. Yeah, I talk about it as often as I can, but a lot of people just kind of don't really think in this way because most software doesn't work this way. You know, you don't have that kind of flexibility.
Yeah. Okay. So this is, you can see that wall sender process is found in the publisher side that actually decodes the wall and sends those changes to the subscriber. And on the subscriber side, you can also see that a logical replication launcher is there, and which spawns the logical replication worker that actually applies all the changes in the subscriber. And then you can see the publication using this short command that to see all the publication in the publisher instance. So you can see that mypub is the name of the publication, and by default it actually replicate all the actions: insert, update, delete, truncate. So you can actually control which actions you want to logically replicate. For example, you want to logically replicate only insert and updates so that you can archive things, don't delete anything. You can also do that. And in the subscriber side, this is the option to see what is the active subscription, what are the subscription are there, whether they are enabled or not, and what are the publications they are connected to. Then we have slots. The replication slots works much like physical replication slots. So you can see that the slot type is logical in this case, and what is the last flushed location, that is also, you can see there are a bunch of other columns also, but I thought this will be useful. And then we have subscription, that also you can see. So this is the subscription. What is the last received wall location? It shows you that. And finally, we have restart replication. Okay, so this tells me that the application name is the name of the subscriber that the publisher is the replication slot is connected to. It is streaming, and this is the last write location. It also shows that, and it also has some bunch of other information, but I think that is same as the physical replication. Okay, so next I'm going to show different syntax we support for logical replication. So the first thing is we can write multiple table names. We can specify multiple table names. We can and then also for a particular database you can publish all the tables. You must be a super user for that, but you can do that. And the interesting thing is you can also mention which actions you actually want to replicate.
Can we also do it at the schema level?
No, it has to be, the table name has to be fully qualified. So you cannot replicate between two different schema.
No. I was wondering if you could say I want to publish everything inside a specific schema.
No, you cannot do that. For now, you
that
cannot
would be
do
nice.
that. Yeah, that will be nice. Okay, then or you can use alter command to add, drop, or set the new tables for a particular publication. And of course, you can drop multiple publication using these commands. Next, this is the command to create the subscription that I have already shown you in the demo. So this is the connection string, and you can mention multiple publication. So our subscription can be correspond to multiple publication. Okay, so this is some extra options that you can mention, you can specify with this create subscription command. So the first is enabled false. So by default, subscription will be created, but it will not be enabled. So it will not receive changes. It will not pull changes from the subscriber. And if you mention create slot is false, then the corresponding slot will not be created from the publisher. So for example, your publisher, it may happen that your publisher is not available at that point, and you have just taken a dump of a database, dump of the subscription, and you want to test it. So you can just load. So by default, pgdump does not create the slot, or by default it sets enabled is false. So you can actually load the entire dump in your replicated server and test whether the dump is properly applied in that instance. And also you can mention the slot name. By default, it takes the name of the subscription, but you can change that. With the copy data option, the initial table synchronization will be skipped. And the synchronous commit works as similarly like the physical replication. So if you set synchronous commit as off, then it will not wait for the wall to be flushed in the subscriber side. Okay. So with the alter command, you can make the subscription as enable. You can disable the subscription. Then you can change the connection string to a new publication. You can also do that, because suppose you have created a mapping from subscription to a publication. Now you want to change that. So with this command, you will be able to do that. And you can also change the name of the slot, or you can set I'm not connected to any publisher. So slot name is none. So when this is useful, suppose your publisher gone down. Now, when you try to drop the subscription, it won't be able to drop the remote replication slot in the publisher. So it will throw error. So in that case, you have to set slot name is not equal to none, or some other slot name also you can specify, which slot name also you can specify, something like that. So after that only you can drop the subscription. So yeah. Next thing is you can also set publication using this command. So by default, refresh, there is an option called refresh. So in a publication, if you add a new table, so unless and until you refresh that corresponding subscription, the new table information will not be replicated to the subscription. So in order to do that, you have to set refresh equal to true, or you can use the next command to refresh a subscription. And similar to publication, you can drop subscription, multiple subscriptions. Okay. So for the security, there are some points regarding security. So the role must have the replication attribute in order to be a replication user, or it can be super user. Super user can do anything, but it is not advisable. So you should create a replication user. To copy the initial data, because it uses the copy command in the table synchronization phase, so you must have select privilege on the published table, or you can be a super user. To create the publication, of course, you have to have the create privilege in the database. Otherwise, you cannot create that. Also, to add a new table to the publication, the user must have the ownership right on the table. Otherwise, you cannot add the table in the publisher. And to publish all the tables, you must be a super user. Also, for creating a subscription, a user must be a super user. So I think we can improve this thing in later Postgres versions, where we can actually, you don't have to be super user to do all these things. That will be a nice thing. So yeah. Then this is the most complicated part that I feel in logical replication. That is the replica identity. So when it controls the amount of information written in the wall to identify. So whenever you want to perform update and delete, you want to replicate it, you need some identifier to identify the tuple in the subscriber side. So this actually replica identity controls the amount of information needed to write in the wall to do that. So it has 4 modes: default, using, index, full, and nothing. I'll go through each of the options in the next slide, and you can modify this settings using alter table command. So by default, it actually takes the primary key of the table. So in the wall, it writes the new tuple. Along with it, it also writes the old key, so through which it will identify the tuple that needs to be updated in the secondary side. You can, instead of primary key, you can also mention an index, but it has to be a unique index, and it must not contain any null values. So it must actually have similar behavior like a primary key. It has to be a unique, not null index. Then you can also specify full. So this is actually the entire old row will be written in the wall. So this is most resource consuming. It takes the most amount of wall, and it is also most verbose. So you can see the entire tuple is then written in the wall. So A, B both the columns, and in the new tuple also A, B both the columns. So, and with nothing, it only contains the new row. So as you can see, it only contains the new row. So with nothing option and with default replica identity, if you don't have the primary key and you would like to replicate update and delete options, you cannot do that. You cannot update or delete in the publisher side because there is no way to replicate those changes in the subscriber side. The subscriber will not be able to identify which rows I should update or delete. Okay. There are some restrictions that we cannot do so far in using logical replication. The database schema and DDL definitions cannot be replicated. However, the initial schema, as I have mentioned, we can use pgdump schema to restore, but all alter table commands, that those things cannot be replicated using logical replication. The replicated table has to be a regular table. It cannot be view, materialized view, foreign table, or partition root table. As of now, we cannot do that, but a patch is submitted for logically replicating the partition root tables. Large objects cannot be replicated. Then sequence data, if you have sequence data in your published table, it will not be replicated. But that is not entirely true, because whatever you are writing in the table, those values will be replicated. But if you try to insert in the subscriber in that column, it will take the start value, because there is no way to, as of now, there is no way to transfer the sequence to the replicated instance. Then bidirectional replication is not yet supported, but I actually like this architecture, which is somewhat you can achieve bidirectional replication. So basically you can use partitioning. So in table, you can partition the two, a particular table. So from server 1, you can publish the partition 1 and replicate to the server 2. And from server 2, you can actually publish the second partition. So this is one way. I'll not say this is bidirectional replication, but something like that you can do. Okay, then these are the configuration parameters that we need to set, we need to modify to control the logical replication behavior. So first thing, wall level has to be set to logical. Then the max replication slot, it is the, because each subscription creates a replication slot, so it should be at least the number of subscription expected to connect. And also for the table synchronization phase, also create some temporary replication slot. So for that also you need some replication slot. So if you are seeing this error, could not create replication slot, all slot replication slots are in use, you have to increase the value. Then for max wall sender, for each replication slot you need one max wall sender. And if you have a physical binary replication, if you have configured binary replication, for that also you need wall senders. So if you are getting this error, number of requested standby connections exit max wall senders, then you probably need to increase the max wall sender value. From the subscription side, you have we have logical replication worker. So there is a configuration parameter that controls the maximum logical replication workers that can be spawned from that subscriber instance. So if you are getting this warning, you have to increase that as well. And there is another parameter, that max worker process, because you have logical replication worker launcher and logical replication worker. So you also have to configure the worker process. Of course, you have to be careful with the parallel workers that is executing in the server. So you have to keep that in mind also while configuring this parameter. Okay, so this is the future scope that we can do with logical replication. Work is going on. excuse me, what work is going on in this logical replication. So the first and foremost thing will be bringing bidirectional replication. It's complicated, but that will be a really nice feature uh, for PG. Same thing, multi-master setup. And another problem that currently we have with logical replication is the long-running transactions. So unless and until we commit a transaction, those changes will not be replicated to the replicated instance. So if you have a long-running transactions doing bunch of huge data changing or bunch of things, and suddenly it commits, there will be a huge amount of a huge amount of changes will be uh, passed through the network. So we want to avoid that, and there is already our work going on, which uh, Amit Kapila from EDB is actively working on that with Thomas Vondra. So we want to do logical decoding of in-progress transactions. And of course, we want to support the logical replication of DDL statement. This is also complicated because when you execute a DDL statement, it does not affect only a single table. There are multiple tables that will be affected. So we want to support that as well. And there will be also it will be nice to have improve the security aspect also. You don't need to be super user to create subscription and all those things. So that will good to have. Okay, so that is all I have. So you can go ahead and ask question. I'll try to answer.
Perfect. Thank you so much. So today, I would say we almost had a record-breaking number of questions. We have so many questions, so we unfortunately will not be able to get to all of them, but we're gonna start knocking them out as much as we can. So one of the questions that came in was, does logical replication support replicating tables between different schemas?
No, it does not. As of now, it does not support. It actually uses fully qualified names, so schema.table name. So it matches that. So as of now, it is not supported.
All right.
So,
The next question that we had was, is logical replication supported in AWS, RDS, or Aurora? Or is it just
yeah. No, as of now, this is native logical replication. So this is only Postgres, but we have logical decoding. And with that, actually, you can configure the logical replication. So native logical replication will not work with that, but you can configure some different kind of logical replication using the logical decoding stuff that we have extension. You can use it as extensions.
Alrighty. Coming up, we have, if the subscriber drops offline, will it pick up intervening changes when it comes back online?
Yes, yes. So it will, if you just do refresh, then it will take all the changes till the last wall location. It will take all the changes.
But you have to make sure that you have enough room on the publisher on the disk, because all the changes will accumulate in the slot, right? So that's something, when you think about the interval duration, you have to make sure that your publisher does not get jammed up because it is waiting for all the wall to be consumed in the slot, right?
Yes, yes.
So
So
the publisher knows all the subscribers, and it's going to hold on to all the data in the replication slot until all the subscribers have gotten the data. Is that what it is?
yeah, so unless and until you drop the slots, so publisher won't be able to remove the walls.
Alrighty. Another question we had was, is cascading replication possible for logical replication?
Yes, you can actually do so. One server instance you can set up publisher, and another server instance you can subscribe to that table, and you can also create publication on that table from that second instance and do subscriber from some third. So cascading replication is possible, but if you have a standby, if you have configured a standby server using physical replication, you cannot create any publication on that standby server. So that is not allowed, but yeah, cascading replication is possible.
Great. Another question that we had was, can we use streaming replication as full failover and logical replication for dedicated data from one master server at the same time?
Yes,
It was a loaded question.
they can work together. Yep. That is a nice architecture.
Yeah. Keep in mind that if you combine streaming replication and logical replication, if the streaming replication participates in a failover, the slot will not be available and not in the same state on the replica, right? So that's not something that Postgres 12 currently supports.
Yep.
Postgres Advanced Server 12 can do that. That capability may be in PG13, that's still TBD, but that combination, yes, as Kuntal says, it works, but after the failover, the slot will not be available and will not be in the same state.
Yeah.
We had another question come in asking about large objects that can't be replicated. So their question is, what is the largest object that can be replicated? Like, what is the threshold?
Oh, I think, Kuntal, you were referring to the large object types, so lobs and clobs, right?
Yeah,
not
large object types.
Size of the object, right?
Not size. Right. That's a large object type cannot be replicated. All
right. And then another question we had coming in was, the next question we had coming in is, can operations be performed on the replicated data before it is written on the replicated side?
Can operations be performed?
No. I kind of filter or something. I don't think we have like a filter capability.
It's not there, right? It is not a committed transaction, so you can't. It's not visible to anybody, right? On the publisher, it's not visible because the transaction is not committed, so nobody else can see it, right?
Yes.
And it doesn't get to the replica, and there it won't be visible until the whole transaction has been replayed, so nobody can see it, right?
Nobody can see it. Yes.
What if you put a trigger on the replica? Does that work?
Yeah. So for the only row level triggers.
Yeah, row level trigger on the replica, and it changes the data that comes in. That would be pretty cool.
Yeah.
I don't know why you do it, but it would work maybe.
That works.
All right. So we have time for one more question. So apologies to anyone whose question we did not answer live. It will be answered, though, in the next few days, and it'll be in the follow-up email. The last question we have is, does the publisher send the logical changes made by an aborted/rolled back transaction?
No, it does not send the changes of aborted transaction. So it actually accumulates all the changes of in-progress transaction in the publisher side. Once the transaction commits, it just sends those. Otherwise, if it is aborted transaction, it just discards those changes. All
right. So thank you to everyone who submitted a question. Remember, if you did submit a question, you can drop your address. I'm giving you time right now. If you're looking to get a pair of our EDB socks, we'll get them to you as fast as possible.
And I got one more request, please. If there are other topics that you would like Bruce and I to address in this series of webinars, please put them into the question box, okay? We're always interested in input. And, if there's topics that you would like to see addressed in this webinar, put them in there and we'll work them into the schedule.
Yeah. All questions will be found on the landing page, which you will receive in your follow-up email. We will be sharing this recording and the slides with you as soon as possible. Thank you all so much for joining us today for our webinar. I hope you have a great rest of your day.
Thank you.